Morning class. Today we're starting a whole new subject, which is transportation planning. So we just finished up traffic signals, and now we're moving in towards more of a theoretical side of this transportation class, an introduction for it, which is transportation planning. And we do have an elective class that focuses on planning, and it's offered every other year, more or less, or whatever people vote for. Typically senior level elective, although some juniors take it as well. That's CE252. So if you like this subject and think it's interesting, there is one more class you can take in this here at Valpo. This is chapter 8 in your book, and so if you want to read through that and catch up on that, that's a good place to start through this. Today we're going to be talking about what the 4-step travel demand modeling process is, and this is a pretty traditional way of looking at travel demand modeling. I think it's adapted over time, but we've had this around for a bit, and it's held up pretty well as a way to describe how decisions are made by people, where they want to go, and then how they choose their travel mode and their route they're going to use. And so again, I'll tell you here in a little bit that this is a little vague exactly how we model this. There's a ton of variables, which makes it a not very exact science, but actually the models don't do too bad given all the wide range of variables that people could use for that. And so we're also going to talk today about what's driving trips and understand behavior through that. And again, so this travel demand modeling, what does this cover? It covers a lot. It goes from as small as you've been hired, so you get out of here and you've got a job as a consultant. You've been hired now to do a road improvement project, and you're reconstructing 2 miles of road somewhere. You have to forecast what the future volume of traffic is going to be on that road. How are you going to do that? Right. And it could be as simple as, well, we know traffic has been growing. We look at the last few traffic counts out here, and it looks like over the last 5 years, we've had a standard growth rate of 1.5%. So we use that 1.5%. We project it forward 20 years. Right? That's one way to do it. You could also do something fancier, and you could do modeling for that and use a regional model to work on that. And there's an agency that pretty much any metropolitan area has. It's called a Metropolitan Planning Organization, an MPO, and that's their job. Their job is to do transportation modeling to help governments in that region do a better job of planning. And part of it is tied into air quality assessments and whatnot. So by modeling cars, we can model pollution, right? Cars are a large part of pollution problems in a lot of urban areas. So that's one piece of it. But the other piece of it, the other service they provide, though, is helping you know if you build this road, how many people can you expect on it? Right. Or if this road has to close for some reason, if you're doing a 2-year-long bridge project and you had to close that bridge for 2 years, where would that traffic most likely go? So you can plan ahead for it and so forth. So that's that modeling piece. So there is a government agency in almost every urbanized area in the country that is in charge of modeling, and you can get forecasts from them through that. And that's the bigger piece. And so there's a wide range of scales. It could be a small road project that you're just reconstructing and you're going to build this road, or it could be a larger regional model. And the South Shore Railroad here near us is building a new line called the West Lake Corridor coming down the west side of Lake County, and it's going to tie in all of those suburbs there into the South Shore line so they can provide commuter rail service into downtown Chicago. Right. So a lot of the reasoning behind why they think they need to build this is modeling. Right? Someone did a travel demand model that said, yes, people from Crown Point will probably ride this train and go into Chicago if it was available, and how many. And if there's enough demand expected, then okay, now it's a good project. It's a feasible project. You don't want to build it and only have 12 people a day riding it. You want to build it and have 20 or 30,000 people a day riding it, especially for a rail corridor like that. Right? So that's travel demand modeling, and it's a wide range of scales. So it goes from individual little projects or way up into a regional planning area, kind of like that new rail project they've got there. So that's just an overview. This chapter covers a lot. It's not a very big chapter as far as length, but travel demand modeling covers everything, covers a lot of scale for that. So let's keep that in mind as we move forward through that. Here's an example, right? So this is this Porter's Vale crossing out here, just east of Valparaiso. Now the Meyer is sitting right here. This aerial was taken. It hadn't been built yet. All right, so now there's the Meyer there. There's the Cinema and all those other stores there. Maybe you guys visit that now and then, this area. All right, and so the city of Valparaiso had talked about once, extending this Porter's Vale Road across the railroad tracks and tie into this neighborhood up here on the north side of the next road up there. And so the question is, okay, that is legit. They talked about this. This is probably 3 years ago. They were talking about maybe building that link to complete out. If you see how it fits into the model here, you've got this road coming all the way down, and then it just ends. Well, if we extended that, that would provide. Actually, then this road goes all the way down to US 30 on the south side. Through there, so you could go from State Road 2 to here up to Porter. This is Vale Park up here, County Road 400 East, or East 400 North, County Road 400 North, I guess it is, up there. So that would create a nice parallel relief to Silhavy as far for local traffic, right? Through traffic is going to use 49, but for local traffic, that would complete this link. That would be an alternate route to take some of the pressure off Silhavy, right, through there, and get people into the shopping complex from this north side. Whereas now they have to come all the way back around to get there, right, in one direction or the other. So, but if you're planning this, how many cars are you planning for? Right. We already know how to calculate levels of service, and we know that, for a certain level of service, we may have to add lanes. We may have to design the road in a different way, but that all depends on how much or how many vehicles, what the volume is that you're going to expect on that road coming up. Right. So this would be an example of where we're going to have to do some modeling, right? There was no road here before, so we can't just take some growth number and add it. Right. So this would be a place where travel demand modeling is really important, is trying to figure out how many cars a day would be on that link. And that will inform us and help us decide exactly how to build that road and how many lanes we need, what to do at these intersections here, and then how it ties into that, and so forth. All right. So that's where that's the reason of this travel demand modeling is this whole thing is how does that all fit in? All right. And traditionally we've got this 4-step modeling process, and we're going to go through these more detail in the next couple lectures through that. But this is I guess a foreshadowing, a little taste of what's to come through that is, this traditional 4-step model you're going to see as we go through each of those steps, what that means and how that's useful through there. But the big questions that we're asking are, where are people coming from and where do they want to go? Right? Where do people live, and where that's typically where we base them from, right? At the start of your day, let's say we reset the clocks every morning at 2 a.m. At the start of that, where are you and where are you going to want to go during the day? Right. And currently you're not going anywhere, right? So you're just going to stay home, and traffic volumes are showing that, right? They're all dropping, and quite a bit, although not as much as they should probably through there. But in a normal environment, right, in the morning, you're going to want to come to campus, right? And maybe you live on campus on the west side in the residence halls or along the north side there, but you have to get over to Gellerson, right? So you're still going to leave wherever you started from. You're going to leave your residence and you're going to go somewhere. If you live off campus, you may be driving onto campus, right? Especially if you're a commuter student, right? And you're going to pull into the parking lots there around Gellerson and Fights, and you're going to be mad because the faculty took all the good spots, and then you have to park out there in the boonies. Or maybe you get there before the faculty and haha, we got your spot through there. But still, you're moving into campus, and then once you're on campus, then you may also walk. Then, right? So this is all parts of these this question, right? Of where you're going and how you're getting there, and then what form of transportation you're going to use. This next question, right? If you live on campus, you may well walk, right? Or you may take a bike, or you may take the campus shuttle around. Okay, or you may ride a skateboard or a scooter or whatever you've got. What form you're going to use, that's one of the questions. We call that mode choice. That's that question there, right? And then once you decide how you're going to get there, what route are you going to take? Right? And you've probably made that decision at the start of classes this semester. What day, when you leave home, depending on what your schedule is that day, what your first class is. Maybe your first class is not in Gellerson. Maybe it's on the other side of campus. You would park somewhere over there. But most likely, most of you now are coming to Gellerson Fights mostly. So if you were driving, you would probably head that way. And probably early on, you decided, well, this road seems to work better. And so you probably picked a route and now you're sticking with it. That's what most people do. That's kind of human behavior. People tend not to try new routes once they've got their preferred one in there. They may play around with it a little bit. I used to like to try different routes now and then just to see if they really were faster. And I was always looking for the quickest route through there. But the route choice is another piece. And that's trip assignment. We call that piece trip assignment when we get there. And we'll go through all that. So this is this human behavior question of where are you and where do you want to go? What mode, transit, cars, walking, are you going to use? And then finally, what route are you going to choose to get there, right? And if we know all of that, if we can kind of predict all of that, we get down to that final piece, that what route, that's when we know how many cars we can expect on a certain road at a certain time, right? That's what we're going for, right? This is transportation engineering. So that's where we're headed is we want to know what route you eventually chose and what mode. Right. So if we're predicting how many people are riding a train, it's exactly the same thing, right? How many people are going to choose train, and then if you don't live real close to one of those new stations on the lake, the West Lake expansion, right? Which station are you going to drive to or ride your bike to, right? That's a question, and then ride the train, right? So there's links. There can be multiple modes in your final trip if you were going to Chicago. Right, just like from Valpo, are you going to ride the little shuttle bus up to Dune Park Station, or are you going to drive yourself to Dune Park Station and ride the South Shore into Chicago? Right. Yes, your eventual choice is going to be the South Shore, but how you get there is also an issue, that matters to us as transportation planners. Right. So that's if we can kind of predict these things and plan them, we can work on that and plan for it. Right. And this is a chart out of your book that shows kind of the decision process. We kind of start at the top and we work our way down. And this is kind of the decisions in the flow chart of how people decide things and how we end up with calculating how much traffic we've got on the highway, on the road piece through there. And so we start out with we call it traveler socioeconomics and activity patterns, right? It's how many trips you take and what kind of places you like to visit depends. And we can find it broadly. We try to, we're trying to model like human behavior across an entire region, which is pretty hard, right? Think about that, trying to model all that stuff across the region. All right, not easy to do, but we can kind of break it down into, people with this income level and with this many kids tend to make these kinds of trips, right? We can, using surveys and other data collection techniques, we can figure that out to a degree, right? Not never perfectly. But if people have school-age kids, it's much more likely, right, that they are going to be driving over to the school now and then. And some people will drop their kids off every day and pick them up every day, right? That's, if you don't have kids, you're not making that trip, right? So you can see how we can kind of segment the population into, okay, if they've got children at home, and based on how many children at home, we can kind of think, okay, well, that's one of their activity patterns, right? So that's a socioeconomic and activity pattern, right? People with a really high income level are probably more likely to drive themselves everywhere, right? And maybe make more trips. I'm not sure that's true, but that could be the case, right? People with only one car and have a family size of 5 are much more likely to use transit where it's available than they are to make vehicle trips because they just don't have enough cars, right? People in a dense living downtown Chicago are much less likely to drive, right? I have a friend who lives in the South Loop in Chicago, nice, apartment building there, residential building, doesn't even have a car. He's got a spot designated in his parking garage, but he doesn't have a car. And so all of their work trips and all of their school trips are made by either mostly walking, but that and transit, right, through there. And occasionally he leaves town and he rents a car. And so that's, based on where they're at and by region, but also that socioeconomic pattern, I guess you would say, we can kind of see, all right, it's not very likely for people living in high rises in Chicago to be making a lot of single vehicle, single passenger, I guess, or just driver car trips. Right? That's not because it's just not doesn't work well in downtown Chicago through there, and they have all these other mode choices. They can easily ride CTA and so forth and get around. So that's that piece, and the way this works is, okay, you decide you're going to travel, and then you say, well, what's available to me, right? So my friend, he doesn't have a car, so mode choice right off the bat, it's probably not going to be by personal vehicle, right? And then we took it at this residential commercial spatial distributions, right? He's in a high density area, right? So that makes a difference on how he's going to travel and where he's going to and what his pattern is. And there's a lot of little shops near him, so he can easily walk to the grocery store and walk to the CVS or wherever he needs to go for that. So that's that distribution of commercial stuff. That's how that fits in. Right. If you live out in the country and everything is 10 miles away, right, you're almost always going to drive. You don't have any other mode choices and everything is far from you. So that's already pushing you that there is pretty much only one mode choice, I guess, unless you're Amish. Then you can take a buggy or a bike. But for the rest of us, we're probably just going to get in the car and drive, right, if we live that far out in the country. Right. And so that finally comes down here. So you decide you're going to travel, what's available to me and how close am I to everything. And then you come down to, well, I'm going to choose to use the car or I'm going to choose to walk, right? And where am I going to go? Oh, I really like that store better, but it's so far away. I don't want to go over there. If I'm just going to go to this close one, I'm just going to go to the Dollar General, get what I need. Yeah, I'll pay 50 cents extra, but it's okay. Right. So there's that mode choice. And that's part of that spatial distribution piece, right? And this fits into it, right? What's available near you and how busy is it, right? And in LA, you never know. Well, I think there's almost always gridlock on the freeways, right? So it doesn't really matter what time of day it is. The traffic could just be terrible, and you're like, and particularly, at 9 in the morning, you're not going to make a trip you don't need to make on the freeway in LA because it is just so terrible trying to drive anywhere, right? So that's going to push you out of choosing that option, or maybe even not deciding not to travel if it's not needed right through there, right? And then once you make those decisions, then you do your choice of your highway mode, right? And so if you chose highway mode, then you're dropping down here, right? And now if you picked pedestrian, or you're going to walk or you're going to ride the train, you move somewhere else out of this chart. This drops down. Okay, you've chosen to use highway mode. And now that you've chosen to use highway mode, what route are you going to take? What road are you going to drive on? And that is affected by the level of service. Well, we've talked all about that, for this semester. How to calculate the levels of service on the highway, right? If a certain road is really terrible, or you feel it's dangerous to pull out, at this one intersection because you can't see well and there's a ton of accidents there, right? That may change which route you take, right? And so it's kind of a loop almost, in that if one road has a really terrible level of service, people stop using it, and then other roads, their level of service drops because there's more traffic on it, and then it's kind of a feedback loop through there. Well, anyway, you eventually make a choice which road you're going to drive on, and now we can predict how many cars are going to be on that road, right? That finally ends up when that's the traffic on that road. Right, so that's kind of that decision tree that it's probably second nature to you, right? You probably don't even think about all of that too much, actively through there. But in the back of your mind, you probably did make all of these decisions somehow. And honestly, quite often, you may only think you have one mode available, right? If you live 2 miles from campus, you're probably not going to walk very often if you have a car and your car is working and in good shape, right? And you don't have transit nearby. So that's a little trade-off there, right, through there. So as we get into this, we should define a few things, right? So we've got a difference between what volume is and what demand is. And volume is counts, right? And so we've talked about this before. Traffic volume is we're counting cars, right? It could be people, it could be transit vehicles, and so forth. But it's something we're counting, right? Demand is the number of people who really want to go somewhere. And so we often say, well, we're travel demand modeling. We're trying to figure out how many people want to go from point A to point B, more or less. Right? Or it's generally actually a zone A to a zone B. You'll see that here in a second. All right, so that's demand. The volume is how many people are actually doing it, right, through there. And so it doesn't always match up, and we'll see that in a little bit. Induced demand, study area and horizon year. So in induced demand, if you fix something, if you add some lanes onto a highway, the level of service improves, right, immediately. And suddenly, people who were avoiding that road before start using it. And so you'll see a bump up in traffic like immediately after a road gets improved, quite often, right, through there. Sometimes people say, well, you added that stoplight and now I hate that road and I don't like to drive through there. So you may actually push a few people away, but normally you see a bump up in the number of people using a new facility. And everybody likes something that looks new, right? So quite often, like if you do downtown revitalization, suddenly everyone likes to come out and look around. And so it looks so nice and fresh, right? Through there. But particularly if you add in travel lane and improve the level of service and reduce travel times on a road in particular, more people will use that road in the future. Right, because, hey, it's nicer, I can save some time, and so you get an induced demand, right? If you build it, they will come, kind of a thought there. The study area is the area we're looking at, right? And so usually these regional models can be quite large, but our study area is often much smaller. And so we'll focus down into that study area to look into that. Tighter scale, I guess you might say. And then what year are you planning for? All right, so that's important. And so these models, they usually have them, they usually do models in 5-year increments. And like the MPO, I think they're supposed to have a 30-year model is like their furthest out model, but they'll have a 5, a 10, a 15, and a 20, and so forth, leading up to that. Right, and what they put in those models are the expected improvements. Right, each of the government agencies in their area tells them, well, in 6 years we're planning to do this, and in 7 years we're planning to do that, and in 2 years this will be built and be open to traffic. They put all that in there, and so then they've got these kind of snapshots every 5 years model. You can kind of see. At least for the projects they see coming and know about, you can see how that modeling will affect, and then they add in the growth factors and so forth, or expected growth factors as we come through that. All right, so travel demand model, we've already kind of hit on this. It's very people-centered, people behavior, right? It makes it really hard to predict, right? And nothing, especially in these regional models, is too exact. Right now, smaller scale, you can get better results, but regional modeling, not very exact, right? We do verification, right? We'll check the future model results, and then we look at what the traffic volume is. But to do that really well, you'd have to wait, the 20 years if that's what you're looking for, and then see, did you hit it right on, right through there. The other thing is a lot of stuff changes you didn't know was going to change in 20 years. Think about that, right? You may have never expected that new Meijer store was going to get built over there in Porter's Vale. It just looked like an empty field, And suddenly that may be driving quite a bit of traffic, right, to that. If you didn't see that coming, obviously your modeling results are going to be off, right? And that's what we do see. We do see a region suddenly develops more than expected, right? They build a new factory, they build some new commercial center here that 20 years ago you had no idea was coming. Right? That's not going to be in that model. Right? So that really throws our things off, and it's kind of hard to verify. Now we build our model, we do verify it with and do validation testing on current traffic counts. So the first thing we check is, does this model actually capture what's happening right now? And that's our best shot on verification, really. And through there, and from there on, it's there are so many variables. It's really hard to see. And this is a thing we should tell civil engineers all the time. Is just because you've got a fancy tool and a really nice equation, don't think that it's going to be exactly right on, right? So these tools we've got, these modeling tools, are going to tell you that, yeah, in 10 years there'll be 17,521 vehicles on that road. Right, that's what the numbers are going to say, right? And 17,521. That sounds really exact. That must be a good model. And then I got this really fancy computer, and I spent $20,000 on this program. This thing is probably really good. No. I mean, it gives you an exact number like that, but what's the plus minus, right? What's your error? Ellipsis on that, right? Your error could be plus or minus 5,000 vehicles, right? So you see, 17,521, that sounds really exact, but that's plus or minus 5,000, right? So just keep this in mind. Even though it may look like a pretty accurate number, it's a false sense of security, right? Just remember all the variables in here that you don't know when you're trying to do modeling, right? There is a huge variance in that, right? And I like to give the example, right? If I were to ask you if I were to tell you right now that the temperature outside is 51.2 degrees, right? Would you believe me? Right? And typically, if you could see me, I'd look at my phone and say, yeah, the temperature outside is 51.2 degrees. Do you think that's true? Right? And the thing is, a lot of people will think, if you told me 0.2, you must really know, right? That sounds really accurate, right? And I can just be making it up, right? And if I just told you it was 50 degrees, yeah, I think it's 50 degrees outside, right? That doesn't sound very exact. You're like, yeah, I don't think he knows. Well, I could be right on. You don't know. But if I say it's 51.2 degrees, everyone thinks, ooh, there's accuracy, right? So that's that false sense of accuracy, right? Even though these models will give you really accurate looking numbers, just remember in the background, there's a ton of variability that can't be modeled well through that. Don't trust them that much, right? Through there. It's a range, right? It's more of an order of magnitude almost. Like if it's within plus or minus 50%, and for a 20-year model, that's considered pretty good. We'll get there, right, through there. Why is transportation modeling hard to get right? Right, it's this, right? In general, we use the 20-year projections for most of our road improvements, right? Land use and zoning can all change easily within 5 years, right? Stuff that you hadn't expected suddenly pops up, right? New developments, that new Walmart, the new factory, the economy can tank, right? Our traffic numbers dropped, and usually they've been increasing, 1 to 3% a year on most roads. And during the recession in 2008, 9, 10, and so forth, we lost traffic on the road. There just wasn't that much traffic, right? Look right now, right now with the coronavirus and the stay-at-home orders, traffic has cratered, right? The roads are much more open in general, right? There's still enough trucks can still run and all that, but the roads have a lot less traffic, right? Who could have predicted that? Even a year ago, who would have predicted that? Nobody, right? So just that's it. Change in culture, which is the how much you want to travel, right? It's commonly been said, the younger generations don't travel as much. They don't go to visit their friends as much because you've got better technology now, right? You can pull your phone out and live stream and face chat and FaceTime, I guess it is, and so forth. Much more easier. And right now, right, we're not visiting anyone because we can't. So we're using technology to connect through that. Another piece in that culture and technology piece is like the ride share, right? 7 years ago, nobody ever heard of Uber, right? And suddenly, a high percentage of trips in downtown cores are being made by Uber and Lyft and other ride share companies like that, right? That has changed the travel demand model, right? Because you aren't driving your car and parking it anymore, so parking isn't as much of a premium downtown. But now you've got these Uber and Lyft drivers who just circle around all the time, so actually the traffic volumes have increased. It's kind of a weird thing, right? So that has changed this travel demand modeling, which if you'd done a model 10 years ago, you wouldn't have predicted any of that. Right? Stuff changes. All right, so let's look at some trip data. This is from the Bureau on Transportation Statistics, which is a federal government bureau that we have, and this is just showing what how many person trips per day, right? How many trips to do anything that you might do per day, on average, by person, right? Do you think you do 3.5 to 4 trips a day? Yeah, well, that's what it's saying. 1995, we had a kind of a peak, more than 4 trips a day, and then it kind of drops off. And this is breaking down by why what you're taking trips for, right? And really going to and from work is not a very big portion of the total trips people take per day. It's mostly family and personal errands. Oh, I forgot that. I got to run over to the store, and off we go, right through there. So that's a big piece of it. Right. And social and recreational, I'm going to go visit somebody. I want to go to the park and so forth. That's another big chunk out of that. It varies a lot by the day. Right. And so you can see that there's very few work trips on Sundays and on Saturdays. And social recreational is huge on Saturday, and family and personal errands also. Right. Through that. So we've got a lot of variability by day of the week. Right. So if we want to know what our weekday travel demand model is, it's very different from what the Sunday one would be, because there's different reasons people are out traveling right through there. And we also we say it's person trips, so it's the number of trips people take, and we're going to focus a lot on cars, and this is why. And the reason is because of all of your reasons. This is by reason to travel that we just saw. Right, based on those reasons to travel, personal vehicle is the number one choice, right? And what we end up seeing is that more than 90% of your trips are going to be made by a vehicle, by a car, basically. And so we do focus a lot on that when we do transportation modeling, because it is the by far largest segment of all the mode choices through there. Now, yeah, in downtown Chicago, it won't be nearly as high there because you got a lot of other options. But most places in Valparaiso, yeah, it's 90% passenger cars, right? And looking at the other side of it, transit, where is transit really big, and where do they have a lot of more transit usage? And this is they break this down by county, so these kind of weird shapes are by counties through there. And obviously out west they have much bigger counties, so that kind of feeds into a little bit. This block right here, that's all LA County. So how is that for the size of a county? It's bigger than Rhode Island. And this is San Bernardino, which goes all the way from Arizona to the coast. So that's a single county, and this is LA County, right? But it's breaking down by county, and you can see this is 10% or more. So even these really dark zones, that's not 90%. That's only 10% of people are using transit, right? So Chicago, even in northwest Indiana, a lot of more people are using transit, well, at least 10% or more, right? Out around New York and the metropolitan area there, DC, yep, Boston area, San Francisco, LA to a degree, Seattle to a degree, not quite as high. Through there in Portland. All right, so those are the big zones, and here's Denver. Those are the big zones where people are using more transit, right? And so density is the main reason, right? Those are much more compact urban environments, and transit makes a lot more sense there and is a lot more economical there. So it's economy of scale, basically. The other thing you can see is where transit is heavily used is often where land use has been restricted. So Seattle is on this little isthmus, I guess you'd call it, between Lake Washington and Puget Sound. There's not a lot of routes in and out of downtown Seattle. It's very compact. transit makes sense there, right? That really forces a pretty high density, right? Manhattan is on an island, right? It forces really high density through there. San Francisco is out on a peninsula. It forces high density, and transit becomes more likely. Well, here's San Francisco, right? Here's downtown San Francisco, right? And yeah, BART has tunnels underneath the bay, and there's rail lines and stuff and everything else coming up along the peninsula, but still, it's that really pushes that density, which is a thing that is very useful for transit. That's where transit works the best, right? So what's causing trips? Why do people make trips, and how they go? What indicators we have? And we'll touch on these more later on. But this is what's linked to it, right? Population. Right? If you've got a low population, there aren't going to be many trips there. Right? Look at rural Indiana, right? We have low traffic volumes out here in rural Indiana because there's nobody living here. Right? There's not much, right? In Chicago, you've got really busy freeways because a lot of people live there, right? And in the suburbs through that. Household type, is it a single family or multifamily in the households? And so what's the density, right? So where those multiple apartment buildings, multiple unit apartment buildings, they're going to drive much more trips because they have a higher density, right? If it's a bunch of single family homes, that's fairly low density. You're going to have fewer trips. What's the employment like in the area? If there's high employment, if you're near a business, factory, manufacturing center, you're going to get a lot of trips coming into that. Income level makes a difference in how many trips people make and what mode they choose through there. The population age, right? People 70 plus don't travel as much through there as much as younger families would, right? Through there, what modes are available? We've already talked about that, right? You only can use a bus service if you have bus service nearby, right? And it's convenient, right? So the mode available. Network capacity, that's the ease of use. And so how congested are the roads? Like, I literally would avoid driving if I didn't have to in LA because it is so congested there. Back when I used to live there. Right, through there. Also, the number of vehicles per household. If we're talking about cars, car availability is a big issue, is a big factor in how many trips you're going to take and how many times you're going to drive. Right. If your car's not home, if it's with your dad at work, you're not going to take it to go somewhere. All right, so that factors in. All right, vehicle or households with more than 3 vehicles make a lot more trips than a household with 1 vehicle. That's what we see in the data coming through there. Right, and what we do is we try to map all these characteristics, and we plot it into zones. And we put those together. We call them a transportation analysis zone. And so we pack those together in a zone. And for that one zone, we try to make them kind of homogeneous. We say, well, these are all single family homes. All right. And so that's a zone by itself. And then if we had a high density housing area, we'd try to probably put that into its own zone by itself. That helps us break these down into cohesive pieces, and so they're kind of homogeneous, right? These are all single family homes and all similar in income level and so forth. It makes it easier to model the trips coming in and out of that zone through there, and we call that a transportation analysis zone. And I'm going to end that here for today, and so that's where we'll pick up next time is talking about these transportation analysis zones and how those factors fit into that.